Hello students, welcome to Vyas Edification Kota. In this session of NCERT series, we'll be talking about NCERT class 11th mathematics, and today we'll be talking about complex numbers and quadratic equations exercise 5.3 as you can observe over here. And without wasting any further time, let us begin with the first question as you can see over here. Let's talk about this question. Solve each of the following equations. We are supposed to solve this equation. This is a quadratic equation as you can note over here, and solving quadratic equations is not very difficult. It is very easy to solve quadratic equations for us. How do we go about solving quadratic equations? Let's take a look at the method first. So for any quadratic equation, ax square plus bx plus c equals 0. We have a very standard approach. We have the Sridharacharya formula and we can use that, right? Some people also call it the quadratic formula, and the value of x, that is solving means finding the value of x. X would be equal to minus b plus minus under root of b square minus 4ac over 2a. This is what we have, right? This is the formula that we use to solve this quadratic equation. That's all, yes. Now, depending upon the values of b square minus 4ac, b square minus 4ac can be greater than 0, can be equal to 0, or can be less than 0. Those are the different cases, right? In this case, what you get is two real and distinct roots. Now, this is the condition when. There's one important thing which you need to note. For this to happen, a should not be 0 and a, b, c must be real numbers. A, b, c must be real numbers. For this to be true, for this to happen, a, b, c must be real numbers. That's very important, right? A, b, c belongs to R and a is not equal to 0. For this quadratic equation, these are the roots, yes? And therefore, b square minus 4ac greater than 0 implies two real and distinct roots. Okay, b square minus 4ac equal to 0 implies two real and equal roots. Then for b square minus 4ac less than 0, what do we get? We get two imaginary roots. Two imaginary roots. Yeah, no, or you can say them, or you can say that these are non-real roots. Okay. And the special thing about these imaginary roots in this case is they are two imaginary roots are complex conjugate of each other, are actually conjugate of each other. What do you mean by conjugate? If you may recall, conjugate, complex conjugate of x plus iy, complex number z, x plus iy, the complex conjugate is denoted by z bar. For z equals x plus iy, the complex conjugate is denoted by z bar, which is equal to x minus iy. And we'll also observe that the two imaginary roots that we obtain are always in this kind of a conjugate complex pair form. Okay. Some people would also be intrigued by this formula and how do we get this particular formula. So I'll give a glimpse of how do we get this particular formula, and let's observe. Ax square plus bx plus c equals 0. For getting that formula, the only thing that is important is a should not be 0. ABC can be anything for that matter. Can be anything means ABC can be any real or any complex numbers for getting that formula. For getting that formula, that's important, right? So we have only used this condition up till now, and once we have used this condition, the first thing that I'm going to do is I'm going to divide by that value a, so that I can convert it into a perfect square, convert this quadratic into a perfect square. X square plus b by a x plus c by a equals 0. This is what we get. And many people find it difficult to get that formula, but then you will not find difficulty in that. Let's observe. I'll try to convert it into a perfect square. What I'll do is, this is a square plus 2 times x times, this becomes b by 2a, right? So I'm trying to convert it into a perfect square in terms of x. So I already have an x square. What I want to create is x square plus 2 times x times something plus that something whole square. Add that. So this is x plus y whole square kind of a thing. And since you have added this, let's subtract this. Plus c is already there. Plus c is already there, mind you. And from here you can note that this becomes x plus b by 2a whole square first. Okay. And on the right hand side you get b square upon 4a square. This minus terms goes over there and that becomes plus, and plus c goes over there and becomes minus. This will simplify to b square minus 4ac upon 4a square. This square equals this. Let's take under root on both sides. Let's take under root on both sides. Let me get rid of this whole story. And once I get rid of this, therefore x plus b over 2a. This is equal to what? This is equal to plus or minus under root of b square minus 4ac whole divided by 4a square under root would be actually equal to 2a. Let's bring that b by 2a on the LHS minus b by 2a plus or minus under root of b square minus 4ac over 2a. And yes, that gives me the final formula. That is what we have obtained over there, right? Is that okay? Yes, that is okay. And on the basis of this formula, I will be solving this question next. X square plus 3 equals 0. Let's try to solve this quadratic equation over here. This is x square plus 3 equal to 0. Now, in this particular quadratic equation, as you can observe, x square plus 3 is very easy to solve. What you will be simply doing is x square equals minus 3. That's very easy to solve, yes. And which gives me x equals plus minus square root of minus 3. Now, square root of minus 3 is something that we are now aware of. I can write it as square root of 3 times square root of minus 1, which is I. And yes, therefore x equals plus minus square root of 3 I is what I get in this question. So that is all in this question? Yes, that is all in this question. What about that big formula, that Sridharacharya formula? We'll be using that formula. We have to solve plenty of quadratic equations over here, and yes, we'll be using that formula also in some of the questions next. Okay? Yes. Let's talk about this one. Here we'll require that Sridharacharya formula. This quadratic equation has 2x square plus x plus 1. It has an a term, it has a b term, and it has a c term also. So let's directly therefore use the Sridharacharya formula and say that x equals minus b plus minus under root of b square minus 4ac upon 2a. In this particular case, this is equal to ax square plus bx plus c, where a equals 2, b equals 1, c equals 1. Can you observe that? Yes. This is ax square plus bx plus c. b is 1 over here, c is also 1, a is 2. So this gives me minus 1 plus minus under root of b square, which is 1 square, minus 4 into a into c. This is what you get. What about the denominator? In the denominator you get 2 times a, which is 2 times 2. What next? This is minus 1 plus minus under root of 1 minus 8, okay, upon 4. This is what I am getting. Therefore, x equals what? Therefore, x equals minus 1 plus minus root of minus 7 upon 4. Now, what happens to root of minus 7? You can also write it as minus 1 plus minus root 7 root minus 1, which is actually I upon 4. And yes, this is my answer for this question. Minus 1 plus minus root 7 I upon 4. That is the final answer for this question, as you can clearly observe using the Sridharacharya formula over here. Right? solve this quadratic equation next. So x square plus 3x plus 9. How do we go about approaching solving this? Why not find the discriminant first? Let's find the discriminant. Discriminant? Which is represented by D is actually that under root term which is b square minus 4ac, as you may be aware of, right? Discriminant is b square minus 4ac in that formula. This under root term is actually discriminant. Okay. In this case, in this question, what is the value of a that you can observe? A is coefficient of x square, which is simply 1. B is 3 and C is 9. Using this, we can find the discriminant very easily. B square is 3 square minus 4 times A times C, which is 9. This is 9 minus, this is 9 into 4, 36. 9 minus 36 is actually minus 27. 9 minus 36 is actually minus 27, and therefore x becomes equal to what? X is minus b plus minus under root of b square minus 4ac, which is minus 27 upon 2 times a, 2 times 1. Under root minus 27 can further be simplified as root 27 times root minus 1. Root minus 1 would be I. Upon 2. This is further equal to what? Root 27, as you may know, be aware of, root 27 is actually equal to what? Let's take a look at that root 27. This is square root of 3 power 3. 27 is 3 power 3, and you can write it as square root of 3 square into 3. One 3 will come out, another will remain inside. What you will have is 3 square under root is simply 3, which comes out. So this becomes equal to minus 3 plus minus under root of 3 root 3 I whole divided by 2. And yes, that is my answer for this question over here. Right? The final answer? Yes. That's the final answer for this question over here. Let's solve this one next. Minus x square plus x minus 2. How do we approach this? The value of a minus 1, the value of b is 1, the value of c is minus 2. That's what we observe. Therefore, discriminant d, which is b square minus 4ac, can be found as 1 minus 4 into a into c. What do we get? This is 1 minus 1 minus 2 becomes, product becomes 2, 4 into 2 becomes 8, and this gives me minus 7. Therefore, x equal to minus b plus minus under root of b square minus 4ac becomes equal to what? This becomes equal to minus 1 plus minus under root of minus 7 upon 2 into minus 1, 2a upon 2a. There was a 2a over here, which gives me x equals minus 1 plus minus root 7 times root minus 1 root 7I upon minus 2, and yes, that is my answer for this question, as you can observe. This is my final answer for this question. Right? Let's talk about this one. Fifth, x square plus 3x plus 5. Solve the equation. How do we go about solving this equation? Once again, this is a quadratic equation, and we can note that a equals 1, b equals 3, c equals 5. For this quadratic equation, ax square plus bx plus c form, we can use this, implying d equals b square minus 4ac. The discriminant equals what? Discriminant is b square minus 4 into a into c. What is that? 9 minus 20, which is minus of 11. Minus 11. And since x equals minus b plus minus under root of b square minus 4ac upon 2a, what does this imply? This implies that x equals minus b. plus minus under root of b square minus 4ac, which is minus 11 upon 2 times a, which is 2 times 1, or we can say that x equals minus 3 plus minus root minus 11 can be broken down into two parts, root 11 into root of minus 1. Root 11 times root of minus 1, which is I, upon 2. And yes, this is the answer for this question over here. Is this the final answer? Yes, this is the final answer for this question. Let's discuss this one next. Sixth, x square minus x plus 2. How do we go about handling this? We write the values of a, b and c first of all. Let's write the values of a, b and c, and after that let's focus on finding the value of discriminant, which is b square minus 4ac, which is minus 1 square minus 4 times a times c, 4 times 1 times 2, which is 1 minus 8, which becomes minus 7. Now this is pretty simple. D is minus 7. We can directly apply the Sridharacharya formula now. Minus b plus minus under root of b square minus 4ac upon 2a, which gives me x equals minus b. Now what is that? Minus of minus 1, which will become 1, plus minus under root of minus 7 upon 2 times 1, implying that x equals 1 plus minus root 7 times root minus 1, which can be written as I upon 2. And yes, that is my final answer for this question. Simple? Yes, very simple. Let's talk about this question. Seventh part, root 2 x square plus x plus root 2. Are we afraid of these under roots, under root of 2? No, we are not afraid of them. What we will simply note is the value of a is root 2, the value of b is 1, the value of c is root 2. Since this is the case, therefore b discriminant b square minus 4ac can also be found easily. This will become equal to 1 minus 4 times root 2 times root 2. 1 minus 4 times root 2 becomes equal to 2, and into 4 becomes equal to 8. This is minus 7. X by the Sridharacharya formula would be equal to minus b plus minus under root b square minus 4ac upon 2a. Now what happens in this case is, therefore x becomes equal to minus b. Now minus b would be minus 1 plus minus under root of b square minus 4ac, which is minus 7 upon 2 times under root of 2. As you can observe, the value of a is root 2, which gives me x equals minus 1 plus minus root of minus 7 is root of 7 into root of minus 1. I whole divided by this is 2 root 2. That is my answer for this question. That is my answer for this question over here. Let's talk about this one. Root 3x square minus root 2x plus 3 root 3 equals 0. What happens in this question? Is it very special? No, it is also simple. The value of a is root 3, the value of b is minus root 2, and the value of c is 3 root 3. Once you have noted these three values, we are simply supposed to find d is equal to b square minus 4ac first. Discriminant. Discriminant is b square, which is minus root 2 square minus 4 times a times c. Let's try to find that. What happens in case of minus root 2 whole square? Minus square is simply plus. Root 2 square is simply 2. What happens in this case? Root 3 times root 3 is 3. Into 3 is 9. Into 4 is 36. Minus 34 is what I am getting as the value of d. Since x equals minus b plus minus under root of b square minus 4ac upon 2a implies x equals, what happens in case of minus b? This is minus of minus root 2, which will become root 2 plus minus under root of minus 34. This whole value has already been found over here upon 2 times this. x equals what? Root 2 plus minus root 34I upon 2 root 3. We can leave the answer at this stage, or we can finally rationalize the denominator as well. For rationalizing the denominator, we'll have to multiply by root 3 in the numerator and root 3 in the denominator. We can leave the answer at this stage, or we can rationalize the denominator. Therefore, x becomes equal to root 3 times root 2, which is root 6, plus or minus root of 34 times 3. What is that? This is 102I upon 2 into root 3 into root 3. What is that? 6. This is my final answer for this question over here. Root 6 plus minus root 102I upon 2 into 3, which is 6. This is my final answer for this question after rationalizing the denominator. Yes? Yes. Let's talk about this. Solve this quadratic equation. X square plus x plus 1 upon root 2. What are the values of A, B and C? C is interesting, 1 upon root 2. This is what we have. Therefore, let's find D first. D, which is B square minus 4AC. What is that equal to? That is 1 square minus 4 into A into C, which becomes equal to 1 minus, what is that? 4 upon root 2. Now 4 upon root 2. 4 is actually 2 into 2. 1 root 2 will get cancelled. This will become 1 minus 2 root 2. Can you observe that 1 minus 2 root 2? This whole value is a negative value. Yes. 2 root 2 is much bigger than 1. And I can write it as minus of 2 root 2 minus 1. Simply this. Yes. Once we do that, the value of x by the Sridharacharya formula is minus b plus minus under root of b square minus 4ac upon 2a. And we already know the values of ABC as well as discriminant D. Therefore, x equals minus b plus minus under root of this whole thing minus 2 root 2 minus 1 upon 2 times a, which is 2 times 1, which gives me x equals what? Can you note that? Minus 1 plus minus 2 root 2 minus 1 is a positive quantity. This is 2 root 2 minus 1 in the under root times root of minus 1, which is I upon 2. And yes, this is my answer for this question 9th. Right? Let's talk about the 10th one. X square plus x upon root 2 plus 1. What are we supposed to do in this case? Let's note the values of A, B and C once again for solving. A equals 1. B equals x upon root 2. The coefficient of x is 1 upon root 2, which is the value of B. C equals 1. Therefore, we can easily find D, which is B square minus 4AC, which is equal to 1 by 2 minus 4 into 1 into 1. What is that? 1 by 2 minus 4, which is minus 7 by 2. Can you please note that? This is minus 7 by 2. By the Sridharacharya formula, x equals minus b plus minus under root of b square minus 4ac upon 2a. Since this is equal to this, which implies x equals minus b minus 1 by root 2 plus minus under root of this whole thing, which is under root of minus 7 by 2 whole divided by 2 times a, which is 2 times 1. This is what I am getting. This is minus 1 by root 2, which is okay, plus minus this is root 7 over root 2 and root minus 1, which is I whole divided by 2. Okay. Can you take the LCM in the numerator first of all? If you take the LCM in the numerator, what you get is minus 1 plus minus root 7I upon root 2, which becomes 2 root 2 in the denominator. You can leave the answer at this stage, or further you can also rationalize the denominator by multiplying with root 2. In the numerator and denominator, what you get is root 2 minus root 2 plus minus root 14 I upon 4. This. That is my answer for this question over here. Yes. And with this, we come to the conclusion of this exercise 5.3 of complex numbers and quadratic equation, the chapter 5 of NCERT class 11th.